Okay, today we're going to look at Lesson 15, and your I can statement or learning objective is I can use synthetic division to divide polynomials. So we're still dividing polynomials, which is what we were doing in the past two lessons, but I'm going to show you another way to do it. You can use synthetic division, and some of you might think it's easier, some of you might not. It's really up to you. When I was in your shoes, I did not like synthetic division. I didn't understand it. I thought it was more complicated. I just liked the long division. But now as a teacher and looking at it again, I think that synthetic is easier. And so it kind of just depends on your personal preference, which one you like better. But if you do like synthetic division, I advise that you use it if you're dividing by a factor that's just x plus or minus a number. So like x minus 6, x plus 10, okay, something like that. If you have a coefficient in front of x, you can still do synthetic division. It's just not as easy. So if you've got a number out front, it's probably going to be just as easy to do long division, okay? So all of our problems today, we're just going to be dividing by a simple factor. Remember, if your remainder is 0, that means that you found factors, okay? Just like if you do 8 divided by 2, you get 4 with a remainder of 0. That means that 2 and 4 are factors of 8. So the same is true with our polynomials. We talked about that yesterday. So what we're going to do today is just work through some examples. You have 3 different types of problems in your assignment, and I'll show you how to do all 3, and we'll practice them. I am going faster in the video than I would in person, so remember that. You're welcome to pause, rewind, watch it at your own pace. And I do recommend that you work some of these out with me just so you know what to do when it comes time for you to do your work in Math Excel. Okay, so we will go ahead and get started with example number 1 here. We have x cubed plus 4x squared minus 8x plus 8 divided by x minus 8. Okay, so this x minus 8 is our factor. And do you remember solving that for 0? So x minus 8, or setting it equal to 0 and solving, I should say. You add 8 to both sides, and you get x equals 8. So that's what I'm going to use. It's the opposite of what I'm given, okay? So I'm going to put 8, and then I'm going to use like this little half of a box, okay? That's how you set up the synthetic division. Now we need the coefficients from our polynomial. The first thing I want to do is make sure that I'm in standard form, and I have all of the terms. So 3, 2, 1, 0. I'm good to go. If you're missing a term, you have to use 0 as a placeholder, just like before. All right, so this coefficient is 1. Then I have positive 4, negative 8, and positive 8. Okay, I'm going to skip a line and draw a nice little line there. You bring your first coefficient down every time. From here, we're just doing the same pattern of multiply and add, okay? So 8 times 1 is 8. Okay, do you see where I put that? Made like this little check mark. Okay, 8 times 1 is 8. Now I'm going to add. 4 plus 8 is 12. Now I'm going to do 8 times 12 is 96. I'm going to add. Negative 8 plus 96 is 88. 8 times 88 is 704. I'm going to add again, and I get 712. Now, this number at the end is always your remainder. Okay? Now, you can build your polynomial a couple different ways. I like to work backwards just because, I don't know, it makes sense to me. And so we'll start with 88. We know that at the end it's a constant. Then we have 12. That the next term would be linear, and then our next one would be 1x squared. Okay? To me, that's easier. If you want to go the other way, that's fine. Just know that your first exponent is going to be 1 less than what we started with, because you're dividing x cubed by x, and that leaves you x squared. Okay? So again, you can do it either way, but just know that's where that 2 comes from. All right? And then our remainder is 712. And that's all you're doing. So again, like I said, you might think this is easier or more difficult. Either way, we're going to practice it today, and then like on the test, you can choose whichever method you like best. Okay, here's example number 2. So x cubed plus 6x squared minus 2x plus 7, all divided by x minus 2. So just like before, we're going to take the opposite of this. So it's a negative 2, so we're going to use a positive 2 because that would be the solution, okay, if we were solving. All right, we need the coefficients. So let's double check. 3, 2, 1, 0. We're in good shape. So my first coefficient is 1, then positive 6, negative 2, positive 7. I'm going to skip and draw a line. Okay, bring that first coefficient down always. Now we're doing that same pattern of multiplying and adding. Okay, so 2 times 1 is 2. 6 plus 2 is 8. 2 times 8 is 16. Negative 2 plus 16 is 14. 2 times 14 is 28. 7 plus 28 is 35. That 35 is our remainder. Okay, we can build our polynomial. So we have a positive 14 on the end, and then we'll have an 8x, and then we'll have an x squared. And then again, our remainder is 35. And just a reminder, you can write that remainder as a fraction, okay? And I think that I just wrote that wrong. It's not 35 out of that. It's 35 over this x cubed plus 6x squared minus 2x plus 7. Sorry, I was looking at the wrong thing. So just remember, you can write your remainder as a fraction, okay? But you guys should be used to that because we've done it the past 2 days with long division. Okay, here's example number 3. We have x to the 4th minus 12x squared minus 10 over x plus 3. Do the same thing as we did before. We want the opposite of this, so negative 3. Bring down our coefficients, but we have 4, 2, 0. So we're going to have to plug in some zeros as placeholders. So we have a 1. We don't have an x to the cubed, or x cubed. We have negative 12x squared. We don't have an x term, and then we have negative 10. Okay, so same pattern as before. Bring down the first one. Negative 3 times 1 is negative 3. We subtract, or add, and get negative 3. Negative 3 times negative 3 is 9. Add those and get negative 3. Negative 3 times 3 is, negative 3 times negative 3 is 9. 0 plus 9 is 9. Negative 3 times 9 is negative 27. We add that and get negative 37, and that's our remainder. Okay, so we build our polynomial. So x, not squared, it's going to be cubed, sorry, x cubed minus 3x squared minus 3x plus 9, the remainder of negative 37. Okay, so in your answer, when you divide, that leading exponent, or that degree, is going to be 1 less than what you started with. So we started with 4, so it makes sense that it's 3. Okay, here's example number 4. Our instructions are a little bit different. It says use synthetic division to completely factor the polynomial. So that means we're going to factor this polynomial. So when we divide, we should get a remainder of 0, making the 2 resulting polynomials factors. And then we're going to see if we can factor it even farther. Okay, so we're going to start out the same way. The opposite of that is negative 5. Okay, our coefficients, 1, 7, 7, negative 15. Same pattern, bring the first one down, multiply and add. So negative 5 times 1 is negative 5, add and get 2. Negative 5 times 2 is negative 10, you add and get negative 3. Negative 5 times negative 3 is 15, add and get 0. So our remainder is 0. Make our polynomial x squared plus 2x minus 3. I'm going to bring down my factor that I started with, so that x plus 5. Now, x plus 5 is as low as it can go. However, this quadratic can be factored, and it's a pretty easy one. So we can just think about the factors of negative 3 that add to give us 2. I'm going to bring down that original x plus 5. All right, so 1 times 3, which one of those needs to be negative to keep 2 a positive? The 1. So x minus 1 and x plus 3. Let's check that. Negative x plus 3x is 2x. So this is your answer. Now, the thing to note on these problems, or depending on what Math Excel gives you, it may already have this x plus 5 there in your answer. So you might just have to type in those next two. Just make sure you look and see what's already given to you. Okay, number 5, we're going to do the same way. Use synthetic division to factor completely. So take the opposite of positive 6 is negative 6. Bring down our coefficients, 1, 10, 19, and negative 30. Bring down that 1. So negative 6 times 1 is negative 6. You add those and get 4. Negative 6 times 4 is negative 24. Add those and get negative 5. Negative 6 times negative 5 is 30. Add those and get 0. That's your remainder, which means they're factors. So we have x squared plus 4x minus 5. And we have x plus 6. Okay, let's factor this trinomial. So bring down your x plus 6, an x, and an x. We need factors of negative 5 to give us 4. So 1 and 5 are the obvious option. We can do 5 minus 1 to give us 4. So x minus 1 and x plus 5. And there's your completely factored polynomial. Okay, and again, just look and see what it's asking for you to type in Math Excel. Okay, our last example is example number 6, and our instructions are a little bit different. It says use the remainder theorem and synthetic division to find P of A. And then you're given P of A is x cubed plus 6x squared minus 5x plus 1, and A equals 2. So the remainder theorem, I wrote it over here to the side. So the remainder theorem says if you're dividing by x minus A, then P of A is the remainder. Okay, so and when it says find P of A, it's just asking us to find the remainder, and that's the information that we're going to give. Okay, so here we're not given x minus A, we're just given what A is. So instead of having a factor like we normally would and getting the opposite, we're just going to use this 2 for our synthetic division. Because ultimately, that's what we were doing before. This is that factor after it's been set equal to 0, okay, and solved. And then we'll bring down our coefficients, 1, 6, negative 5, and 1. All right, bring down the first one. 2 times 1 is 2. 6 plus 2 is 8. 2 times 8 is 16. Negative 5 plus 16 is 11. 2 times 11 is 22. 1 plus 22 is 23. That's my remainder. So here you could write out the polynomial if you want to, but we said that P of A is the remainder. So if it wants to know P of A, we're just going to tell them the remainder, which is 23. Okay, so that means if A is 2, this is in function notation. If we plug 2 in for A, which would in turn go in for X, we would get 23. Okay, so I think you have 2 problems like this in Math Excel, but when it says find P of A, it's just asking you what the remainder is, and we know that that works because of this theorem. Okay, so use these examples to help you with your Math Excel. If you get stuck or have questions, as always, let me know. I would be happy to help you. So hit Ask My Instructor, send me an email, hop back in the Google Meet, whatever you need to do. But I hope you have a great rest of the day, and I'm here if you need me.